In the previous videos, I've discussed what happens to you when you travel in a lift in various directions. So what I'm going to do now is just look at the actual maths behind that. Now, we've looked at it as a lift as a whole, but what happens when it's a person stood on the lift floor? Now, obviously, we've talked about reaction before in the general forces unit. And obviously, if a person of weight, of mass m kilograms, stands on the lift floor, there's an mg pushing down on the lift floor. And equally, there's a reaction which is equal and opposite to the weight acting upwards. And it's the reaction that I'm interested in the three cases listed here. Now, the lift I'm going to talk about is moving downwards. And initially, in stage 1, the lift is accelerating downwards until it reaches constant speed. So there's no acceleration, which is stage 2. Then stage 3, the lift starts to decelerate before reaching the ground floor. So if I look at stage 1, this is where the lift starts to accelerate downwards from a stop motion at the top of the building. If I apply F equals ma in the direction of motion, which is downwards, you can see I've got the weight acting downwards. Take away the reaction of the lift floor is equal to ma. So in this case, reaction is equal to mg minus ma. And you can see here that the reaction of the lift floor on the person is actually less than the weight of the person because we've got this minus ma. That's why you feel that light feeling when you suddenly start moving downwards in a lift. If I apply F equals ma to the second situation where the motor has stopped accelerating the lift, it's moving at constant speed now, I have mg minus r is equal to 0 because the acceleration is 0, it's moving at constant speed. So rearranging, I get r is equal to mg. So in this situation, the reaction of the lift floor on the person is equal to the person's weight, so effectively the person doesn't feel a thing. That would be the same as the person at the start of the motion where there's no acceleration, there's no motion, they're just waiting for the lift to move. If I then apply F equals ma again in the final situation, so the lift's still moving downwards, but now it's decelerating, so the acceleration is moving in the opposite direction, I have mg minus r is equal to minus ma. So rearranging this, we get r is equal to mg plus ma. So the reaction of the lift floor on the person is now more than the person's weight. And that's where you get that feeling of weight pushing against you as the lift starts to decelerate. So again, you've got this feeling of heaviness. So there we have our three situations. The first situation is where you get that light feeling, the mg minus ma is the reaction on the person. Then you have the r equals mg, where you feel that nothing is happening. And finally, you've got that r is mg plus ma. When the lift is decelerating, you get that feeling of a weight suddenly pushing against you.